All right, so this is now the next part of u substitution, which is we're going to be using u sub for a formula. So what we're looking for is that 1 over 1 minus x squared. So we're looking for this one. Remember, the numbers themselves we can move around and manipulate. So this is what we want, is this form here. So let's go look back at our tables and see what we get. So looking at these, we can say, no, do you see it yet? Yeah, right there. So that's it. So that means the integral of this would be inverse sine of x. So we need to create the 1 over the square root of 1 minus x squared so that we can make it into inverse sine when we take the integral. So we know this will become this. So now all we have to do is a little modifying to make it work. So if you remember, we'd say t is equal to, and we need to have that 9 minus x squared be 9 minus 9t squared, so that we can take and factor out the 9 and make it into a 1 minus t squared. So whatever number we have here, we need to place that in front as well. So we need this to be 9t squared is equal to x squared, which means 3t is equal to x. And so now when we integrate our derivative, we take our u substitution. This would become 3 dt is equal to dx. Well, now we plug everything in. So we have 3 over the square root of 9 minus, and again, our x squared is 9t squared. And then our dx is 3 dt. So we end up with the integral of 9 dt over, and we can now factor out that 9 like that. And so we end up with, we're going to take those numbers out. This is 9 divided by 3, which is 3. And there it is. So now we have our integral. And that's a t, so that would just be a t. So we have 3 inverse sine of t plus c. And then we go back up and grab it. So what is our t? Well, our t would equal to x over 3. So we have 3 inverse sine x over 3 plus c. Now this wasn't the only formula. Some of you were probably thinking, hey, we can use our trig substitution. Yes, you can. So we had 9 minus x squared here. So we could just look and go, oh, well, if we just say x is equal to, well, if that's 9, that would be 3. So x equals 3 sine theta, and we can convert it into a cosine theta. So why don't we try that too? So let's do it again. This is the whole point. If you can find multiple ways of doing it, you really should. It's just practice. That's what you're looking for here. It's like if you saw a Rubik's Cube and you solved it, your next step will be go, well, that was the easiest way. Can I do this quicker? So we know that we need to have our x equal to 3 sine theta, because we want this to be 9 minus 9 sine squared theta, so we can convert that into a 3 cosine. So that means dx is equal to 3 cosine theta d theta. And again, it's a good substitution because everything disappears. That's what we were looking for. 9 minus, and that will be 9 sine squared. 9 sine squared theta. And then dx is 3 cosine theta d theta. All right, so now we put this together. This is 9 cosine theta d theta all over, and we'll take it slowly, square root of 9, square root of 1 minus sine squared theta. That looks horrible. Let's try that again. Sine squared theta. That looks better. All right, I'm going to zoom in now. So again, 9 over 9. See, there's your 3. And then we have cosine theta over cosine theta d theta, which just becomes 1. So we're going to rewrite this as 3 d theta. And what's the integral of 3? It's 3 theta, right, plus c. Now, we didn't start with a theta. We started with an x. So we've got to come back up and go x equals 3 sine theta. So if I divide by 3, remember, just like we did over here, we had to rewrite the t in terms of x. So now we're going to write the x in terms of theta, or theta in terms of x. X over 3 equals sine theta. So that means theta is equal to the inverse sine of x over 3. So 3 inverse sine x over 3 plus c. Do they match? Look at that. They do. So the whole point what I'm getting at here is to not just look at these problems and go, okay, there's only one way of doing it. Sometimes there is, but most of the time, not most of the time, yeah, I gotta say most of the time, that there are multiple ways of getting there. We have a lot of different techniques for U substitution. So just try something. Say, I'm going to try this or I'm going to try that. They work most of the time.